Thank you, everybody, for let me present you as a presentation about developer experience, about Playrix, about how we change the developer experience in our company. And I hope this information will help you in your own company to understand the importance of the developer experience as a whole process, and maybe to take some recipes or tips and tricks from my presentation and implement it on your own projects in your own companies and make your developers more happy and more productive. So let's start. My name is Ilya Bogin. I'm working at Playrix and I'm a technical producer. I will say a couple of words about what is exactly the technical producers at Playrix a little bit later. But let's start from the Playrix. I hope that most of you has already known this company and maybe even play our games, maybe even on a regular basis play our games. But if you have not know anything about Playrix, let me give you some brief numbers and brief description about what the Playrix is. We are the number one mobile game publisher in Europe. We have more than 3,000 people who are working on those games, and our players, our active players number are much more than 100 millions of people per month. That's very, very large number. So yes, we have a lot of work to do and a lot of games which we have worked on. But let's look at the Playrix from the developer point of view. What are the Playrix? What is the Playrix if we are a developer or if we are in charge of developers inside of the Playrix? We have more than 10, 10 different projects at different stages. Some of them are major game projects that has already been launched and have a very large number of players. Some of them are just started their way to the success, and some are at the middle. If we talk about the number of the developers, so we have more than 500 contributors. So we are using GitHub as a repository. So the number of GitHub contributors are from 500 to 1,000. It depends how we measure it, whom we included and whom not. We are develop the games based on our own game engine. It has both advantages and disadvantages, of course. From one side, we have the full control of everything about the game engine. We can improve the performance, we can add the features when we want it and how we want them, but we are as a full responsibility of what happened with our engine. So there is no somebody who can fix or improve or add some functionality if we do not do it by ourselves. Our projects are about several millions lines of code if we talk about the project size. And our main platforms for the players are iOS and Android, of course. Also, we support the web. But if we talk about the developers, they are mostly worked with builds on Windows, macOS, or Linux. So we have to support a large number of different platforms as a build targets. And our release cycle is about 1 per 6 week. And we want to improve it, and we want to um, submit our games more often. But let's talk about it in detail a little bit later. So this is some information about the Playrix and who am I? I'm a technical producer. I'm not the developer and I'm not the engineering leadership. So I'm not the head of engineering or some head of some development team. I'm more like a product owner, but from the technical point of view. So I'm responsible for the strategy for the formulating what should we do as a technical platform and how we should implement different development practices, and then help the teams to use those practices in their real work. So this is what technical producers are doing at the Playrix. Now let's go to the developer experience. Developer experience is a very, very broad term, and even we have not the short name for developer experience, which are used by everyone. Different companies, different peoples use different terms, DevX, DevX, DX, and also there are different names for almost the same thing as a developer experience. Some named it engineering effectiveness. Some named it engineering excellence. Also, there are the term from the LinkedIn, which I used in the LinkedIn company, and I'm also fond of this name, developer productivity and happiness. Why do I like it? Because it describes what do we want from developer experience. We want our developer to be productive, and we want them to be happy. Uh, so there are different names, different short names, but when we talk about developer experience, everybody, not maybe not everybody, but most people agrees that when we're talking about developer experience, we are talking about productivity and the satisfaction of our developers. Let's start from the developer satisfaction. Why it is important for us? No, first of all, we love our developers and we want them to be as happy as possible in our working environment. The second reason why it's important for the company is because of the developer retention. Because if the developer are not happy in our company, they will change the company. And our turnover rate, attrition rate will be much higher than we want. And to getting the new developers is a large, is very complex work because first of all, you need to find the developers, and when you have found him and get him to your company, you need to introduce him to your working environment, to onboard him, and this can take a lot of time. It can be even months for the new developer to get to the optimal performance stage. So if your developers goes away, your overall performance will not be at the optimal stage. It will be every time it will be near the middle, and it is not what we want. Also, the last but not least is that the developer dissatisfaction can be the top of the iceberg, and the problem can be much more bigger and much more complex. The underwater part of the iceberg can be that you have very high level of the technical debt. Maybe you have very non-optimal processes, and if you focus and try to understand why your developer are dissatisfied, maybe you will be able to find the main problems inside the organization that prevents you to develop faster, develop better, develop with better quality. So developer satisfaction matters, and it is very important. But it's hard to measure. Let's talk now about the productivity. I am want to introduce you the quote from the Laura Tahoe as the CTO of DX company. It highlights very interesting problems about developer productivity. If we ask different groups about what the developer productivity means, we can receive very different answers. If we ask the engineering leadership, they will tell us about the value about how much value we generate, about whether we will be able to ship the new features at the right time. Are we working efficiently? But if we ask the same question to our developers, they usually gave us very, very different answers. They will talk about how much code have we shipped in terms of code, in terms of lines of code, in terms of pull requests, in terms of tickets. And this is a very, very different metrics. We can try to summarize it as two kind of develop productivity metrics. Some of them are value oriented. So we try to estimate how much value we achieve during our work. And other metrics are process oriented. They tell us about how optimal and how fast are our processes of code and feature delivery. What should we do with these different type of metrics? The engineering leadership, as you remembered, would like to use value-oriented metrics because they are more important to the company. The company wants to bring the value to create the new games, to add the new features to the games, to ship these new features as fast as possible. But when we are talking with the developers, we are talking mostly about the process-oriented metrics. Process-oriented metrics is required, but they may be not sufficient enough to get the good value-oriented metrics. But there are main consequences. If we had bad process-oriented performance and bad processes, so we have non-optimal delivery process and we have slow delivery process, we almost impossible to achieve the good value-oriented performances. It's hard to get the value to the company, to our gamers, to our players, if we do it in very non-optimal and in very, very slow way. So yes, we need to achieve the process-oriented performance and to improve process-oriented performance as much as possible, but we should understand that it may be not sufficient. So we cannot just stop at this level and say, okay, we have shipped as many PR, as many code as possible, and that's okay. That can be not enough to get the real value. And this is the important point. So I hope that you understand that the situation is rather complex and we have a lot of problems when we try to do anything with the developer experience. We do not understand what exact metrics we should use. We do not know how we can measure either productivity or either satisfaction. And also, we do not know yet how we can influence what should we do to improve these areas. Because to do something, we need an object. We need an object which we should focus on, which we should improve. So let's talk about it. What are the objects which we can influence when we talk about developer experience? With what we should work to improve the developer experience? There are different approaches of trying to understand what are the objects when we're talking about developer experience. There are, of course, the space framework, and we will discuss it a little bit later. But I am fond of the following framework, which divide the developer experience on the three main areas: feedback loops, cognitive load, and flow state. Let's try to understand what are they exactly. Feedback loops is the processes when the developer receives some feedback about the changes that he has made. For example, our build or our test failed. This is a feedback. Or QA checks the feature and finds some additional bug. This is also the feedback. Or we have the crash report from the production stage. This is also the feedback loop. We have received additional information that helps us to improve the code quality, to change it, to make it better. The cognitive load is the area about how complex is for developer to introduce the new changes. What are required? How many steps should be performed by developers to implement the change and to deliver the change? And also the flow state. This is the area about the optimal state. Are we at the optimal state of performance or not? Maybe we can do better, but something prevent it. So what prevent it and how we can overcome it, this is the area of the flow state. It can be a little bit complex. So let's try to describe it on some example which are not connected to development at all. For example, we want to get some packages from the location A to location B, and we want it to be done as fast as possible. What can help us, or what can be the problem during this way? First of all, feedback loops is about the roads itself. They can be straightforward from A to B, or they can have a lot of detours or some complex roads. And of course, the more straight and the more easier is the road, the faster we can get from point A to point B. The cognitive load can be described as the quality of the road. If the road quality is good enough, we can move as fast as possible. But if it's not good enough, we cannot move as fast as possible, and we need to slow down because the quality is not very good. And the flow state is about interruptions. If there are a lot of traffic lights during our way and we need to stop at each traffic light, we cannot get from point A to point B very fast. But if we have the green line, when all traffic lights are green, then we can move much, much, much faster. I hope that this metaphor will help you to understand what are exactly feedback loops, cognitive load, and flow state. But how do we use it in a process of improvement the developer experience? Let's go deeper and decompose the feedback loops at the different stages. So what are the different feedback loops which are used in almost all of the projects and which are also used in Playrix in our game projects? First of all, the first feedback loop, almost first one, is the local build and testing. So you receive the feedback whether your changes has been able to compile or have been able to interpret it if you use interpreted language or transpiled language, and are your local tests are green or broken. Then, when you have finished the changes, you can make the pull request, and usually there are some builds that are running upon this pull request to check its quality, and there are also code review by your peers or by your team leads to check some additional qualities, attributes, properties of the changes that you want to make. After this, there are at some point check by quality assurance, or also the check from the product management, who tries to understand whether this change is really doing what they wanted to do or not. And also there is feedback from the real users and some product and technical metrics from the real product after it's submitted. So these are the different feedback loops. And of course, they have different metrics. So we can measure the performance of each different loop and can try to improve the speed of each of the loop. The better will be the speed of each loop, the better will be the overall productivity, the better will be the time to market of our features. So what we have done at Playrix? Of course, we have started to measure all these types of all these different steps of feedback loops, but also we decided to introduce the concept of green master because we think that it is very, very important to make the feedback loops as fast as possible. But let's first try to understand what is a green master in our terms, what we try to achieve using this approach. We say that our branches are green if, first of all, they are ready for development of new features. Every developer can check out this branch, make the new branch, and start the development. There is nothing that stops him. For example, if the branch does not compile, it really stops you. You cannot try to add new feature if currently the master is your branch is the broken state, it cannot be compiled, and you need to wait for the fix. The second main properties of the green branch is that it should be ready for testing. The quality assurance or automation test should be able to be launched at any moment to check whether we are ready, for example, for submit, or whether one of the feature are ready to submit or not. If they cannot do such a work, we cannot move faster. And how it influence the overall time to market and overall performance. If we implement the green branches, when we talk about the green branches, we usually talk about the green master branch and the green release branch. But this term can also be applied to some other branch. For example, you can try to make almost all of your branches, the feature branches, the team branches, if you use them as a green. But we are focused on master branch and on the release branches. So one of the main properties of the feedback loops is that they are ordered by timeline, and the latest feedback loops require much more time to be if something has been broken than earlier feedback loops. So saying it a different way, if some problem has been founded only at the latest stages, for example, in production or only during regression before the submit, it requires much more time and much more resources to be fixed. And if you will be able to find it and fix it at the early stage, you will spend much lesser time and much lesser resources. And the Green Master help us to shift these quality gates, shift the number of problems that we have found it at the earliest stages as possible, before the changes has been merged to the branches. So this is why Green Master is important. And if we implement it, we will be able to drastically increase the overall speed because we will spend less time on fixing the problems because we will be able to find them on the much earlier stage before they have been merged to the main branches or release branches. So we decided that we need green master, but how we can achieve it? We cannot say, okay, now the master and release branches are green and everything will work. No, we need to do something to make it work. We have chosen the 10 steps which should be performed by the project one by one from point 1 to point 10 in this order to achieve the green master. Each project uses this as a path, as a plan, and move with its own speed during this plan. And the platform team, the developer experience team, helps the projects to move through these stages and to implement all of these required changes. So if we are trying to achieve something, it will be very helpful if we can measure whether we are already at this point, or how long should we have to go before we have been able to achieve the green master. So we introduced the green master metric, and it told us how can we calculate it. We calculate it on the base of how much time per month the controlled branch has been green. How we can measure it? We create the regular builds. In some companies, they call it nightly builds, top-notch builds that are launched on the regular basis, once per day or maybe several times per day. And if this bundle consists of different builds, it can consist of 10 builds or maybe more, and has some complex dependencies inside of it. But if any of the builds inside this regular check bundle has failed, we treated the overall check as failed and said that this branch has been broken. Then we use a pessimistic approach to estimate the time, how long the branch has been broken. We measure that it has been broken from the time of the last successful build until the time of the next successful build. All of this period we threaded as a period of broken branch, and it will decrease the percent of time when the branch has been green. And we use it as a target, we use it as a metrics of how close are we to the green master itself. So we choose the targets of what we should do to improve the feedback loops and how we should measure our progress through this process. First of all, this is a green master, which we have discussed before, and our target is 100% of green state. We want to be at this point. And the second and the third metrics are the time of local build and the time of the PR bundle. We have a target about 1 minute average for local build time. We want, in average, the local build time to be under the 1 minute. And for the builds for the bundle, overall bundle, which launched during the pull request check, we want it to be near 1 hour. Also, this is a interesting point. Should we do PR bundle less than 1 hour or not? Of course, if we make it more faster, the overall time to market should be a little bit faster too. But it can maybe you should add additional checks, additional bills to this bundle, because if your green master is not green yet, it means that you should add additional checks to the earlier stage, to the pull request bundle. And if you are not yet at the 1 hour, maybe you should add additional checks and not decrease it more, because 1 hour from our point of view is good enough. And if you make it faster, maybe you should add additional checks, create additional automation tests, increase the percent of smoke, etc. So this is our targets. Also, I would like to highlight some problems with choosing the right measure. We have talked about we should measure the build time, both the local build time and the pull request build time. But how can we measure? What we should use as a measure for this time? There are different approaches. We can use average or mean, it is the same. Or we can use, for example, the percentiles, the 50th percentile, P50, or 95 percentile, P95. What is the better? What should we choose? The mean, the average value, is much more descriptive because it's much closer to the overall experience. But it has a problem of high noise because when we talk about measuring the duration of some processes connected with the build, it's a long tail distribution. It has very, very long tail, and the average in such case can give you very, very noisy results because some rare builds, but with a very high time, with a very high duration, can bring your mean, can give also the peak at your average level. And it's very hard to check whether you improve or not if there is a high level of noise. So there is a problem with the average, with using the average as a measure. The standard way in such situation use the percentile because the percentiles are much more better working with noise. They are not affected by the rare peaks because of their nature. They just take all the bills before, and they are not looking at the bills which time are more than which are for example the 5% of the lowest build or the 50% of lowest build. They are looking only on the fastest build when calculating the real value. But the problem with them is that they are not very descriptive. You can see the real value from our charts, and you can see that P50 is very optimistic. It's not getting us any information about what are the experience of the 50%, is this very very large number of the 50% of more lower bills. They may be very very low. We don't know because if we look just at 15 percentiles, the P95 is very very pessimistic. It's also not very descriptive because you can see currently it displays us 20 minutes, and this is not the real experience. This is a rather rare experience. And if we improved it, for example, from 20 minutes to 10 minutes, it does not tell us any information about the real experience of the users. Maybe they will stay the same in terms of average value. And maybe it gives us worse average value or better. So working with a percentile also has its own disadvantages, but they are much, much better working with the noise. And we decided to use a little bit uncommon metric, which named Winsorized mean. What does it mean? The Winsorized mean. We for the bills for the values that are larger than P95 value, we do not use the real value. We use a saturation at P95 value, for example. You can Winsorize on different levels, but we use the P95 saturation. So if there are rare bills with a high duration, they will add to the average value, not their full value, but only the P95 value, which is 20 minutes in case of this chart. So this gives us the both advantages. It is much, much more, it has much, much lesser noise, but it is very very, very, very descriptive because it describes the real experience of the user. So what we are doing exactly, what the steps are we performed to improve the feedback loops. First of all, we try to implement the 10 steps to achieve the green master, and also we improve our build time. To improving the build time, there are 3 main areas, and we try to do different projects in each of this area. First of all, you can try to do it faster. Try to build faster. You can use more powerful agents if we talk about for example, TeamCity, or you can improve and upgrade the local computers for the developers. And so you can try to do it faster. You can try to profile the build, to find the bottlenecks, and also to improve it. So this is about do it faster. Also, the important approach is to try to reuse the previous results because usually builds are not launched once. If we change something, we regularly build it. The PR bundles are regularly rebuilt on the same branch with the different additional changes. So if we can reuse the results using the local cache, the distributed cache, it can decrease the time required for rebuilding this build. And also we can try to do it in parallel. If we can decompose it on different steps, on different jobs that can be launched in parallel, we can do it much, much, much faster. And we have done the projects in each of these stages, in each of these areas. At this slide, there are some tips and tricks that we have tried, that we have achieved as a new knowledge during this process. Um, I will not get in detail because we not have very, very large time. But during the Q&A session, I can try to answer your question, or you can try to connect with me, and I will also answer you and give you more detailed description about these tips and tricks and what we have achieved. Okay, I think this is all about feedback loops. Let's go to the next area, to the cognitive load. First of all, what we want to achieve when we talk about cognitive load. We want our developer to be at the following state. I, as a developer, fully understand what are required to implement these changes. And all the steps are automated as much as possible. I do not need to do a lot of manual routine steps to finish the work. What's the problems? It's hard to measure and it's hard to improve. Let's try to decompose it. We have asked our developers and try to find the main areas connected with the cognitive load that can be improved that affect their work. And we have found the three main areas. In your case, it can be a little bit different, but at Playrix, these are the three main areas that that are non-trivial as they require a lot of additional cognitive load. First of all, this is a setup of the new target platform. The second one is to find the info how to implement the change. And the third one is to implement the change itself because of the complex architecture of our project. And we have started with knowledge management. This is about the information, getting the information of how to achieve, how to understand what should be done. What are the main problems during this way in trying to find what should be done and how can we do it? First of all, the information in a big companies, and Playrix are very, very big company, the information is scattered through different sources. There are a lot of different wiki style documentations. There are Slack channel with a lot of additional information. Some information are kept as the comments, in the comments or in the README files. And it's not easily understandable where should I go to find how to do something. The second problem is that the search results can give you not the one answer, a number of documents, and to get the real answer, you need to combine the information from those documents. The third problem, we do not understand the quality of each part of the documentation, of each part of our knowledge, because it's very, very scattered, and we do not understand what exact searches has been done, and whether the author of this question have found its answer or not. And also because currently most of the company are spread around the world and we are working in a distributed team, in a multi-language team, there is a problem with the language because people speak different language, and it is also the problem. So how to fulfill these problems? What we should do? We think that we have found the silver bullet. Of course, it's not silver bullet, but it looks very, very promising. We use retrieval augmented generation plus general LLM approaches to process all the documents, to all the different sources. So we collect through connectors the information from all of the possible sources. It doesn't matter where the exact knowledge has been introduced. We use connector to get it to the same RAG vector database. Then we have minimized number of entry points. For example, Slack bot, web widget, maybe some additional integration through IP. We ask each user to give us a feedback because we have the minimal number of entry points. We can integrate the feedback solution to each of these points, and we ask everybody to press like or dislike if the answer the quality is good enough or it's not good enough, and we should improve our knowledge. And it helps us to create a pipeline to understand what exact areas of knowledge are not sufficient and what we should improve based on uncertainties of the answers by RAG and LLM and based on the user feedback through dislike. And also, it's language transparent because the modern LLM can answer in any language. It does not matter for them what language has been used as a source. They can easily create the answer on the target language. So it helps us as a language transparent solution. As for developer assistance, we are just at the beginning of this way. We are using Copilot, but we are not understand exactly what we are achieving, whether it really improves and how much it improves. So currently we are only at the beginning of this way to really improve the cognitive load by using the AI code assistance. Let's go to the flow state and why it is matter. If we are at the optimal state, if we're in the optimal stage and writing the code, and something interrupts us, we cannot return immediately to the same optimal state. We need some time to refocus and to get to the same state. Usual estimation, it can take up to 30 minutes to get in the optimal state. So if such interruptions are often enough, you can be optimal. It can be in non-optimal state all of the time. So what we have done to improve it? We try to control the number of meetings for our developers. We try to make them as effective as possible, for example, using document-driven approach. And we try not to interrupt all of the users. If there are some operational work, for example, it can be done by some developer who is on duty, and only he will be interrupted and not all of the team. Also, when we talk about developer experience, we need to understand how to make it work as a pipeline. Because yes, we can make certain projects to improve the feedback loops, the cognitive load, the flow state, but how to make it work as a pipeline with the constant improvement. First of all, who can work with the developer experience metrics and with the developer experience solutions? It can be the platform team who is responsible for developer experience, for example. It can be the engineering leadership, and it can be the team leaders who are working directly with the developers. What we want to create, what kind of pipeline we want to create. We want the team leaders to be the main leaders in this process. They should use their own team specific dashboards to understand what happens with their own team. They should try to use the recites and implement it to improve the developer experience. And when they cannot do something by these recites, they should escalate this problem to the platform team. And the platform team should prepare such a guidance should create such a dashboard and helps to automate to collect all these metrics. And the engineering leadership helps in this process to prioritize everything and to supply the resources which are required to fix the developer experience. So we try to move the focus from the development team and from the engineering leadership to the team leaders itself, because they are much, much closer to the developers and to their problems. Also, let's talk a little bit about metric frameworks, because it is much better and much useful not to try to create your own metrics, but to use the standardized metrics frameworks for developer experience. There are a lot of different metrics, but I would like to highlight the two different types of metrics: self-reported and system. For example, if we ask the developer how much builds have you done through the day, and he answers us, I think it's about 10 or 20 builds. This is a self-reported metric, self-reported type of metric. If we use some special script which sends the event when any local build has been launched, this is the system type of metrics. Both of them are important because some areas can be measured only through self-reported metrics and some only through system. And when we have overlap, when we have both self-reported and system, we can get much, much more broader view on the subject. If we talk about the frameworks, the most famous one and the most used one are the Dora, Space, and DX. The Dora is the oldest one, and I think the most known, and I think most of us has been met such a metrics framework. But from my point of view, it's not very useful for game development and for mobile game development. It has been created for DevOps, and it is very operational. It is very focused on operational level, and it's not cover all of the problems and all of the aspects of mobile game development and game development itself. The space has very broad view, but it's not exactly about the metrics. It's about the areas which you should be focused on. But it's not told you about the exact metrics which should be used, for example, to measure the satisfaction and well-being of the developers. It can be used as a framework to think about developer experience, but it's not about the real metrics. The DX4 looking the most promising because, first of all, it's about the real metrics that can be measured. And also, if you remember to the beginning of our presentations, I have told you about two types of productivity measurement: measurements through value and measurements through speed of the process speed. And DX score looks on the both of the types of the metrics. The speed and effectiveness told us about the quality of our delivery process, and the quality and the impact try to estimate the value of our work. So it looks very promising, and it also includes the developer satisfaction through the effectiveness by using the surveys, developer surveys. So what next? Where are we at the project at the Playrix right now, and what we are plan to do in the next stages? We need to finish all the all the projects that we have started. We are not finished them. So let me use a quote of William Churchill. We are just at the end of the beginning of these processes. And we would like to try the DX Core 4 framework to overall to make the overall metrics for the overall processes. And we will make more focuses or making developer experience improvement as a pipeline and work at the team leaders level. And I hope that I will be able to uh, meet with you maybe next year and told you what we have achieved during this way and what interesting tips and tricks and what knowledge we have achieved, and we'll be glad to share it with you. So thank you very much for your attention.